Here, I'll see if I can open it on my phone. I think I already had it downloaded.
Better luck using Falcon, regular Falcon.
It's going faster?
Yeah. I believe so.
It's going on.
Yeah.
Yeah.
It's going on, yeah.
I just live, you take whatever this road is, and the road that you're not supposed to drive on, drive down.
The road that you're not supposed to drive on, everyone drives on.
Well, I live down there, so I can drive
I was
on
just
it.
gonna say, you know, down there it's different. And they try to make it so that you don't want to drive on it because they pumped the speed limit down to 30.
That's so stupid. Like, they said in the thing that's supposed to actually be 40 because of how the traffic flows.
All right. Well, did I already start the recording? I did. Okay. So in any case, let's, while it loads on multiple devices here, I have it trying to download the thing on my phone at the same time. And it is slowly going. So just as a reminder where we left off last time, we are working on a tool that reads in a bunch of distances. So these are the putts and how much they missed by, right? The center of the hole. Actually, these were angles, right? Offset. Okay, so that's what we read in here. Didn't we do the math for those? Oh, we did the inches to degrees here. So really what we need to do is if we go backwards, if we take, these are the degrees. If we took in number of inches, what if we wanted to write degrees to inches to go the other direction? If we wanted to convert all these to inches. Because realistically, when the person's entering information in here, they're going to be entering in the amount of the distance missed between the center of the cup and where the ball is, not the angle, right? We're going to need to convert to the angle. So we have this number here. Oh, we figured that out last time, didn't we? So we're going to be putting in a bunch of inches. But I want to write the other, I want to go the other direction. We were originally thinking that this was inches, but it's actually degrees, correct? So I want to write a function here. Static double degrees to inches. That takes in a double degrees as a parameter. Okay, and so how do we go backwards? It's got to be the inverse of what this guy does. So what we did here is we took number of inches, we converted it to feet. Then we got the radians for that by taking the arctangent of feet divided by 10. And then we called it the 2 degrees function of Java to convert the radians to degrees. So if this is how we get the radians, how would we get the feet? If we have the radians, so if we have the angle 3, what did we decide the distance missed was for 3? What did we have to pass in here? Wasn't it something like 6 point some inches? Here, let's, well, I was going to say we can do it at Google. Oh, here, 6.28. We had it in there. Okay, so 6.28 inches should give us something around a 3. I think it was 2.88 or something like that. But should give us something around a 3. All right, so we want to be able to take in the we want to be able to take in the 3 here and get the 6.28. Okay, so I want to be able to take in the number of degrees and get 6.28. First of all, is there a math.to radians? Yeah, there is. Okay. So we're going to be taking a number of degrees in degrees. We need to first convert that to radians. Okay, so now we have our degrees in radians. How do I get that converted into feet? Or reversing this. So I want to say double feet is equal to something related to radians. Let's go back to our picture. If I have 6.28 inches, I'm trying to figure out this angle right here, correct? So what's this angle? Opposite over adjacent. What's opposite over adjacent? That tangent? It's tangent, right? So this will be math.tangent. And what are we going to do for our tangent? We're going to say this number, which we do not have, is equal to 10. So what we need to do is we need to solve this. The tangent of my radians variable is equal to x divided by 10. Right? I'm trying to figure out this 6.28. We have it written here, but that's our x. That's our variable in this example. Radians was passed in. So we're going to get a number of degrees here. We'll convert it to radians. Now, once I have that, here's my formula. This is the algebra. How do I solve for x given this? If I divide both sides by x, I get a what? I get tangent radians over x is equal to 10.
This is not how math. Yeah, never mind. You're right.
That work? I divided both sides. The x's on the right cancel out. Now we have tangent over radians here. Okay, so we can calculate tangent over radians. That's a real number, correct? Well, how do I get that by itself? How do I get an x equals out of this? Well, I multiply both sides by 1 over tangent over radians, or tangent of radians. That should give me 1 over x is equal to 10 over tangent of radians. Does that get us anywhere? Let's take our tangent of radians.
You should just multiply by 10.
We could multiply by 10.
The original.
Well, hold on. What do you mean multiply by 10?
The original,
Radians
just multiply
times
by 10.
This guy?
Yeah.
Oh, you want to take this times 10.
Yeah.
Okay. And that gives us x. Like that?
Yes.
Okay. So now, we want to return Well, we need to get it in feet first. So this will be, we know it's 10 feet, correct? Because that's how big of a putt this is a 10-foot putt. Times math.tangent of what? Radians. And then we have it in feet, so we'll return feet divided by 12 to give us our inches. Feet times 12. Oh, no. Yes. Feet times 12. See, I need my coffee. It's terrible. All right, so if we were to pass in driver dot degrees 2 inches and we passed in a 3, we're hoping this gives us something like 6.28 ish. Okay. Now, reason for that, we want to be able to read in, realistically, our given information in the document, which we'll open as soon as we can open it, has a bunch of radians, okay, a bunch of degrees. But when the person is measuring this information, they're reading that information in, they're going to probably be entering it in terms of number of inches. So we're going to need to have that conversion. So we're going to need to be able to pass in a number of inches, convert it to degrees in order for us to fill up our array here. That makes sense? Why are these from 2012? Another 45 minutes. Let's see it's load. Let's see if it's loaded on here yet. Oh, it did. It did load on here. Now it's still thinking. Okay. So now that we have those couple of conversions, assuming we've already read stuff in, a bunch of inches, converted it all to radians, we create our new aiming object, passing at our putts. What does the aiming object do? The constructor takes in that number of those putts, the array of putts in radians, goes through. Right now, it's doing total misses. We're saying total misses in inches, but we don't have that in here, do we?
No, this is left over from when we thought we were working with inches.
Right. But we were also, why won't this open? Their document had some given information that I wish I could show you. Try Res Hall.
You have 4G at your phone.
I do, but I have like 2 bars. Let's
Not only does Concordia's internet not work, Concordia's cell phone service in the building suck too.
unless you're on Sprint.
Yeah.
Then it's got all bars. It's just slow.
It's not that slow. It's pretty
Sprint.
slow.
Okay, hold on. It's opening.
Just because it has like one negative up and down.
I want to see whether or not they summed up the, whether or not we want to take in inches here and have it do all the conversions internally. I'm on my 4G there, which is not very good, seeing as though it says 4G, yet Mac 1 is an LTE. Can we do this? Let me try giving myself a hotspot.
Go on Falcon, it's so much faster.
I was already on Falcon.
You're kidding.
It wasn't working.
Yeah.
Yeah, see, I was on Falcon here a second ago, and
Oh wow, it's magic. Third from the bottom.
ah, download. All right, we're in business. View needs to be rotated left, correct? Where's my rotation?
And tools.
Rotate left. Okay. So, here were their inches when they did the total distance in inches. That was 11 point. They had 11.5, but that appears like it's adding up the radians, doesn't it? Set up 10 putts from 10 feet. Record how far from the center of the cup each putt was in inches.
I don't think the radians would be such good numbers though.
So the question is, do they want this in radians or do they want this in inches? So here's the inches to degrees. That's the from 10 feet. This summation they have here, the 11.5, is the summation of radians, correct?
There's no way a radian's going to equal.
Well, you add all these up, you get 11.5.
Those are inches.
Well, it says inches, but it's not inches. Because you see over here, here's your 3 degrees in radians is, well, rather, this is 3 degrees. This is in degrees, 3. So 3 degrees is equal to 6.28 inches. They said, here's the aim in inches, yet these are all the degrees. Correct?
Making me work for it.
So I'm trying to figure out what they mean. So this is not total distance in inches. This is total degrees missed.
Well, and then their instructions on the top just make it more confusing because they're only referring to inches.
Yet they do have a conversion here. So aiming handicap, we get our average distance in inches which gave us a 0.8, which put us at an overall handicap of 4. So I don't think they want distance in inches. I think all of these things are, this is total degrees missed, average degrees missed. So your handicap is based off the average degrees missed. So this is based off of how inconsistent your miss is, or how consistent your miss is. Does that seem to make sense?
But what if there is 0 degrees miss and you're short 3 inches? Then how would that go?
Well, this is just aiming. This guy's just aiming. Next screen, I think, deals with start line, and the next one deals with, is this the lag putting? Last one's lag putting. We'll flip-flop it once we get in there. Okay, so what it seems like we need to do is we need to take in all of our putts in inches, convert them to radians. From there, we deal with our radians. We sum all that up. No, not radians. Convert it to degrees. From there, we sum up all our degrees. We get our average degrees. And that gives us our handicap. We need to decide how our pro points work. So pro point for aiming is less than 1 inch right or left. So if we are less than 1 inch right or left, is that 1 inch or is that 1 degree? You see, they awarded them a pro point in all these places where they had 1 inch. Well, they say 1 inch, but it's actually 1 degree. These people are killing me here. So less than 1 degree. Well, first of all, it's less than or equal to 1 degree, not 1 inch. This starts to make more sense, though, as long as you try to extrapolate what they meant instead of what they say. Because an inch from the center of the hole means you made it. Correct? So they're awarding a pro point every single time that your miss is less than or equal to 1 degree. We get a pro point. If pro point is made at a 0.5 inch, 2 degrees. So since we have a pro point here, what do they mean? Now, what's actually entertaining about this is not necessarily dissimilar to what you'd run into working with clients, where you get information that seems correct but isn't really correct, and we need to figure out what this information actually means. 10 putts for 10 feet. Got that. Record how far from center of the cup each putt was in inches. That's what we're going to be doing each time. So our tool is going to have them enter in 10 number of inches from center of cup. Fine. Circle if pro point. Pro point is for aiming is less than 1 inch right or left. My feeling is that is an inch, not a degree. If they're 1 degree off, that's probably a miss. Correct? 1 degree meant, well, 1 degree was a 2 inch. It's probably a make. It's probably right on the edge. I think a cup is 3.5 inches. So they're saying a pro point would be, left edge to right edge. So within 2 inches, 2.09 inches miss. Or 2.09 inches from the center, whether it made it or not. That's a pro point.
4.25 inches in diameter.
Is the cup?
Yeah,
Okay. So this seems to support that then.
still make, yeah.
This is a make or burning the edge or something, or whatever. It's that seems to be within the cup. So that seems to tell us that this is not an inch, but rather in degrees. Less than or equal to 1 degree is a pro point. Okay.
But if it's 1 degree from the center of the cup.
Well, we're going to be converting all of our distances into degrees. So, for instance, what this basically says is if their miss was more than or was less than or equal to 2.09 inches from the center of the cup, we're giving them a pro point.
Right. But the cup is the diameter of the cup 2 point.
No, he just said it's 4.25 inches. So this is rough. This is a make. So this basically says if you made it, we're going to give you a pro point. Okay, so if we made it, we're going to give you a pro point. But they are doing it off of the degrees, keeping in mind that these round. So it appears to me that anywhere between 0 and 0.5 is going to be once we do our conversion, we're going to round to the nearest half. Is I think how they're going to do it. The nearest half degree. Because all of their measurements here are in steps of half a degree. Okay, so less than or equal to 1 degree after rounding is a pro point. So they gave pro points here based on all of these things that were less than or equal to 1. How do they use a pro point? So this is total degrees missed. This is average degrees missed. Our aiming handicap was average degrees missed. Overall handicap was 4. Total distance, which was this 11.5, plus total pro points. Huh? What was this guy on when he wrote this? I'm thinking this is not total distance, but rather handicap. So handicap plus total pro point rounded is 8. I don't know if they're ever using that 8, but that appears to be the situation. Anybody have any drastic reasons why that's not the case? So this is total degrees. This is total pro points. That's fine. This is average degrees missed. This is average degrees missed for your aiming handicap.
So what did they add to total pro points to get the 8 at the bottom?
The average. I'm thinking they take 7 plus 0.8 rounding to the nearest half, which gave us...
So what are they talking about in the directions for add 0.5 inches? Is that ever...
Three, 4, 5, 6, 7, 8, 9, 10, 11 and a half. Okay, so they're definitely not adding anything there. We have our pro points, that's 3.5. Well, we could also say total degrees missed minus, if we say half a degree for this, that's 3.5. So 11.5 minus 3.5 is 8.
It's new now.
Or is it add 0.5 and then round it to the nearest?
Yeah, but it's add 0.5 what? Well, this says if pro point is made at 0.5 inches.
Wait, so how are they getting 0.8 again?
0.8, if we treat all these as radians, 0.8 is 11.5 average, or 11.5 total degrees missed, divided by number of putts made, which was 10, gives us 0.8.
11.5 divided by 10 is not
No, that's right.
0.8.
How did we get the 0.8? All right, hold on. If we do 11.5 minus, what's 8 divided by 10 is 0.8. That's where it came from. So they took this. Okay, no, we're good. We're good. They took this number, which is the average degrees missed, not inches. Average degrees missed. They subtracted from that the degrees gained by total pro points. We had 7 pro points, so we get a half a degree, not a half an inch, half a degree for each made pro point. So this comes out to 3.5. So we're going to take 11.5 minus 3.5 to give us 8. 8 divided by total number of points is 10. So 8 divided by 10 is 0.8.
So it should say minus instead of plus.
Well, let's just say a lot of things. This should say minus total pro points times 0.5. This should not say total distance. This should say total degrees missed. Okay, so let's. I think we have an understanding of it now. We just need to get this down on some paper. Wow. What's actually amazing is the number of things they consistently got wrong. Isn't it kind of like somebody did? But they did the math right.
That's their own document.
Yeah, it's like, yeah. See, these are a number of inches. No, they don't. This is all private at this point, so it's probably a good thing. Okay, so we're gonna read in a bunch of inches. We're going to convert those inches to degrees. So for starters, let's go back to our code. Let's figure out what the inches version of all these are so that we can load those into an array. Okay? Let's just print them initially. So we'll go through all of our putts. For each putt, we will convert it to inches. The putts at bucket I to inches. So we should get 6.28 followed by some other crap. Okay, so those are all of our putts, inches. I'm going to load those into an array. I'll truncate a little bit. So this is 6.28, then 1.05, we'll just truncate, 1.04, then 2.09, and realistically, nobody's going to measure putts this accurately. You know, they're going to say, yeah, this is about a 2-inch miss or 2.25-inch miss or something like that. But This will at least make us get our numbers correctly. 1.04, 2.09, 0, 4.19, 3.14, and 2.09. Okay. Let's just make sure we get the numbers we think we should be getting here. Make sure our conversion goes the other direction. Seems legit enough. Okay. That's fine. Okay. So these are our putts we measured in inches. We're going to need this function inside of aiming to convert those to degrees. So I'll go ahead and put this down here. We'll make it a private function. Okay, so let's rename some stuff here. This is total missed degrees. This is average missed degrees after pro points. I really feel like it's very necessary for us to name these very explicitly at this point. Okay, average missed degrees after pro points. Private int total pro points. Okay.
Wouldn't it have been easier to do that thing that you did last time, not change everything?
Oh, probably refactoring it?
Yeah.
Yeah, probably, but I didn't do that. Okay. So we're going to start off our total missed degrees. I'm actually going to store a couple other things up here. I'm going to say private double array the putts inches, private double array the putts degrees. So right off the bat, we're going to say this dot the putts inches. And we're going to call this guy the exact same thing. So we know exactly what this guy is taking in as a parameter. So this dot the putts inches is equal to the putts inches. Now we need to convert that guy into our degrees. So we're going to say the putts degrees is equal to a new double array of size the putts inches dot length. So we'll make this array of doubles have the same number of buckets in it as this array of inches. So our array of degrees is going to be empty currently, but it's going to have enough buckets to store all the degrees for each putz that was passed in. Then we're going to loop through. For int I is equal to 0, I is less than this dot the putz, doesn't matter which one we used, inches dot length, I plus plus, because these are parallel arrays, right? These two arrays link up with each other. We talked about parallel arrays in here, didn't we? Okay. So we're going to say the putz degrees, well, here I like using this dot, at bucket I is equal to this dot inches 2 degrees, this dot the putz inches at bucket I. So we'll put at bucket I of the putz degrees whatever the putz in inches is converted to degrees. So that's what this loop does. Fills up our putz degrees. All right. Now at the same time, we had this dot total missed degrees start off at 0. We can go ahead and sum that up in here too. Correct? So I could say this dot total missed degrees is equal to the putz degrees at bucket I, and we'll say plus equals. So we'll add on to our total missed degrees whatever the degrees we just calculated is. Then we also need to keep track of pro points. So we're going to need another variable. This dot total pro points start off at 0. Now, it appears to me, if we look at our document over here, that it's always rounding degrees. Wouldn't you agree? 0.5, 1, 1.5, 2, 2.5, 3. So let's go ahead and inside of our function for inches 2 degrees, before we return it, we're going to say math.round. Okay. That should round it for us. So total missed degrees plus equals the putt. Then we'll ask if this dot the putt's degrees at bucket I is less than or equal to 1. This dot total pro points plus plus. Make sense? So, what does this stuff do right here? This loop goes through, converts all inches to degrees, sums up total degrees missed, and counts total pro points. Make sense? Now, we have to calculate our average. So averaged mixed degrees after pro points is equal to, we need to get our average degrees. Actually, no, we need to get our, this dot total missed degrees, subtract from that this dot total pro points times 0.5. And then what are we going to do with that? We're going to divide that by this dot the putts degrees dot length. And the math we just did there is this guy. Sum it all up, subtract from that this number, total pro points times 0.5, so that'll be 3.5. So 11.5 minus 3.5 is 8 divided by 10 will give us the 0.8. Make sense? So this is the 11.5 in our example. This is the 7 in our example. This times this is the 11, or is the 3.5 from our example. 11.5 minus 3.5 will be 8. So all of this here will boil down to our 8 from our example. That stuff. All of that boils down to our 8. And then we're going to divide that by however many putts there were, which in this case is 10. That should give us our 0.8. All right, now here is our scale for points missed, or our average misses and handicaps. So we probably don't want to call this, well, average misses is fine. It's related to this. And the related handicap. So we'll go through, this is average missed degrees after pro points. So if that's less than the 0.9, then we'll return a 4. Otherwise, if it's less than 1.9, we'll return a 3, so on and so forth. So at this point, we know the handicap is set correctly. And what I'm going to do for right now is I'm going to come down here and I'm going to get rid of all those getters. And then we'll just use the built-in ability to generate them again. Source, generate getters and setters. We want, but actually we want deselect all, select just getters. So we want to give us getters for all of our private things. Do we want them to be able to get total pro points? Yeah, it's fine. All right, so there's all of our getters. So we'll come back out here. Crater aiming, pass at the putts. Total missed degrees would be A dot get total missed degrees. Average missed degrees after pro points be A dot get averaged, and then we'll get our handicap. So this should give us 11.5. This should give us the 0.8. And then this should give us the 4. All these are right, but the total missed degrees was not right. Seems like maybe that took some of the things that should have been point. Just for the sake of argument real quick, I'm going to take the rounding out. I want to say we probably took some things that were 0.5 and set them to 0. Yeah. So total missed degrees is 11.4. Average missed degrees is 0.79. Handicap was 4. So that rounding did not work the way we wanted it to work. So is there any reason why we can't just leave it summing at all like this? It's getting us accurate answers. If we come into total missed, what if we round this? Let's see, rounding's truncating. So why does it say rounding?
Or was it rounding to the nearest?
Oh, yeah. Is there a better rounding function in here? All right, we're gonna have to write our own rounding function. So if I have a number like 11.47 and I want that to be 11.5, how would I do that? At what point would I want that to be an 11.5 versus an 11.0? At 11.25. So if I took 11.47 and I subtracted from that 11, I would be left with the 0.47, correct? So that gets me that piece. How do I do that math? How would I accomplish this in Java? Could I say 11.47 minus the integer version of 11.47? Would that truncate that? If I forced that second 11.47 into an int? So I could say something, if we come back out here, go into driver. Let me just comment all this again real quick. So we'll have a val is equal to 11.47. We'll do system.out.println val minus the integer version of val. And hopefully this gives us 0.47. Then we can ask the question.
It wouldn't round at all, would it, if it was above 5?
Huh?
It wouldn't round up if it was above 5, would it?
If it was above 0.75, we'll have to ask the question. So we'll say, actually, let's put this into a variable.
Not to like stop everything you're doing. Like, can we use decimal formats?
Use decimal formats from the class decimal?
Yeah.
We could. But I'd rather do the direct math this way. Okay, so diff should be equal to, in this case, the 0.47. If diff is and actually let's say double base is equal to the int version of val. We'll just say base there. Actually, this guy could be an int base. So if diff is less than 0.25, if that's a true statement, then what are we going to do? We will system.out.println base, just to display the stuff. Else if diff is less than 0.75, we want the 0.5. Else system.out.println base plus 1. So for 11.47, this should give us 11.5. For 11.25, this should give us 11.5. For 11.24, this should give us 11.0. For 11.75, this should give us 12. 11.74, this should give us 11.5.
What about 11.5?
11.5 should still be 11.5 because we do it off the base.
Okay.
So we say if it's less than 0.25, then print out the base. If it's less than 0.75, 0.5 would be between those two. Then we're going to print out base plus 0.5.
Okay.
That makes sense?
Mhm.
So now we can wrap this into a rounding function. Static double round. It takes a double val as a parameter. Steal this code for a second. Then we'll have our base. We'll have our difference.
You gotta make base a double then, because otherwise it'll try to return the.
No, I can just. And that's actually, we don't need that many parentheses. I just being explicit.
You can hit return. Type return.
Oh, thank you. Else. And actually, we could just say base here. We don't need to convert that. I think we could just say base here as well. Okay, so there's our little round function. So now we can say system.out.println driver.round, passing it val. So it should be 11.5 this first time. .22 should give us 11.0. 11.74 should give us 11.5. 11.78 should give us a 12. Okay, so we have a nice round function now. So go ahead and steal that. We'll go into aiming. We'll create a private round function in here. We'll say this dot round math dot 2 degrees. So we're going to use our own round function to do this. Go back to driver. Don't need any of that anymore. .5, 0.8, handicap 4. Okay, so now we are capturing total inches missed from the center into an array called the putts, passing the putts into our constructor for aiming. We are then building the putts in degrees, initializing missed degrees and total pro points, going through, filling up our putts in degrees by converting all of our putts in inches, summing up total missed degrees, summing up total pro points. Then we're calculating our average based off of missed degrees and pro points. This is our scale from last time, which is based off of this guy up here. Okay. And ultimately, we're setting a handicap. So our code right now should properly do aiming and give us a handicap on that. What we'll do on Thursday is we will try to decode start line and see how bad they screwed that up. They also have short putting, so there's 2 on one screen here. So hopefully there's only so much they can mess up in this one. Okay, so I'll see everybody on Thursday.